So now I'm going to start my introduction of my final project program. Um, as you can see, the name of my game is Escape. This is a small game for relaxing. Players will control running blue box and they will have to avoid collisions with obstacles in different sizes by clicking the space button to make the box jump. Actually, I got this idea from the Chrome browser, and there's a little T-Rex game inside. And got my idea from it. And as you can see, this is probably how my program works. There's a players will control the T-Rex and T-Rex will keep running. And they have to jump to avoid the obstacles, and if you hit them, then you are died. Let's go to my game. Now hit the play button. Actually, they're very similar, but my program is more maybe there's more bugs in my program. Yeah, I did. This doesn't count. So my program do the same thing. So as you hit the space button, then the blue box will jump in order to avoid the collisions with the obstacles. And as you can see, the obstacles they're speeding up as your score goes higher. Also, the distance between each obstacles are different. This makes the game more fun. And the speed of this game is much faster than what it used to be, so it makes the game harder now. Now I died. So let's go over the coding stuff. So in the in my main class, I will open a new opening screen. So let's go to the opening screen class. As you can see, I have been described the classes and comments the stuff. So as you click the play button, then it will open a new main user interface game. Then if you click the exit button, then it will exit the game. Let's go to the main user interface. So these are the properties of it. And Here's a key if it's and you can see right here it will create a new engine to control the game, to make the game works. But first of all, let's go over the player class and obstacle class. And both of them are game objects. So see the game object class. Actually, they just did a few things like detect the key press, but they're important. And now let's go over the engine class. That could be the most important class in this whole game, and it's pretty complex for me. So all of these methods to make this, they can make the game works like what I expected. Now it's the constant class. There's just a few little stuff inside. Some of them will change and some of them will not. And now, now let's go to the coordinate class. So that could be another big class in this program. And you can see the coordinate class it makes the object moving and detect the collisions between objects and objects. So it is another important thing in this program. And last but not least, here's my toolbox class. And as you can see, I made this class a long time ago before this final project started. And what I'm trying to do is to make the world easier to make me do the stuff more quickly. Yeah, so I think that's all I want to introduce. And if you want to know more about it, you can see the introduction and the conclusion that I write the and the comments and description inside the coding stuff. And also there's a few things that I hope I can make some improvements. So first of all, the constant class. I think that this for variables just too I think I can make more than 4 variables because in the engine, as you can see in the engine class, there's a bunch of variables, and in the coordinate class, yeah, also a bunch of variables. So I hope I can move all of them into this class to make makes the things easier to see. And also the, as you can see, the player class and obstacle class, um the game object class, they're um almost empty. Actually, I hope I can move some of the stuff inside, like inside those 3 classes, like the um let's see, for instance, the move method in the coordinate class. They would be more accurate if I move them into the obstacle class. And plus, if I move the jump class into the jump method into the player class, it could be easier to understand. But that would be a great work for me to do. Maybe I will do this later. And also, my game is kind of maybe too hard to play when you get a very high score. So I hope I can make this game kind of easier for players to use. Yeah, that's all my introduction. Thanks for your watching.
In today's video, I'll be looking at my final project for computer science 40S course, and for my project, I have created the 2048 game, pretty famous game, and I wanted to put a little twist to it because I'll just show you now. When you run the project, you're able to select the game mode, and here I can go classic, which is the 4x4 grid, but you can go with survival and actually change the size of the grid. So here's a 10 by 10, as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 by 10. And the screen changes with it. If I go back to the menu and click classic, you can see the screen changes with it. And I'll be going over the code and the functionality of that in just a moment. And when you perform any moves, it works just fine. The two tiles combine to form the next tile, and as you can tell, they're all bases of 2 because they always double when you combine the two matching tiles. And as you can see, I have two 8 tiles in the last column, and I can simply just add them, and I'll make 16 there. So I won't continue anymore with that. So the goal of the game is to reach the 2048 tile, but it doesn't actually end there. You can keep going to 4096 and so on. And here I have an instruction panel. It just gives you the controls up, down, left, right, pretty simple. And you can go back to the menu, and I'm just going to quit for now and go over the functionality for the code. So I'm using a JFrame to create the frame that I'll be rendering. And most of the code actually occurs in the game board class. And the game board class, this includes basically all the movements and the functionalities for it. Here we see the method that creates the board image, and I'm only going to go over this once because I do this quite a bit of times. I use the graphics 2D utility library, and this is how I create the game board. So I set the color, and here you can see it's commented dark brown, and I create the canvas of which I will have the board in. Now, a lot of these methods are just there to simplify the logic of the code, but I'm going to be going over the push right method and push left and so on. So this is a recursive function, and the reason I'm using a recursive function is because if I run the game again, this matrix, this matrix here, whenever I push it to the right, what's really happening is it's checking the next one to see if there's anything empty. And if there is, which in this case there is, it's going to move here and then make the previous one empty. And it's going to keep doing that till it reaches a boundary. And the boundary here is going to be the end, which is the last column. So once I move it, that's exactly what happens. And then a new box spawns, and that's basically how the game works. And when I combine the two tiles, whatever added number I get is also the score that I get here. You can see I just got 4. If I do that again, I'm about to get 8 here, and 8 plus 4 is indeed 12. So now I'm gonna just show how this works. If you're adding the first right box here, if you're the whole column, this one might be easier if I just if you're adding the whole column, basically the last column here, if once you've reached this last column, when you're pushing to the right, you don't need to keep anymore, so you just return. And if the box is empty, then there's no point in moving it, because these are all still a matrix array of numbers. In fact, the empty boxes are just zeros, but they're just not shown. But if they're empty, or if they're 0, there's no point of moving it to the next box because I only want to move the numbers. And so next I'm going to be talking about is once in the right is added, you have to return it, and this is quite important because you need to be able to get the older box. And I've also made this get box method which will get the coordinate for the box, which helps in actually moving it to the next box. And then I have an isAdded function, which keeps count of whether it's added or not, because then when you know it's added, you can actually continue to add the tiles together. Because now isAdded is not true. Once I add it, now it's true, and it resets it and updates the next move and so on. So now what you need to do is, this is the actual logic here, is you got to check if it is occupied, the next row, basically the same, I mean the next column, sorry, the same row, see here, row 0, you got to check for column +1, which is right here, and you can see that here it's not occupied, so you can indeed move it, and it recursively checks it, because right here you call the push right method again, which is, well, the original method, and that is a recursive function. So if it's not occupied, you're going to move it. And there's another case where if it is occupied, but it's occupied by the same value, here you see I'm about to push it to the right. This next box here in the last column is occupied, but once I push it to the right, they can be added because they're the same value here, and you can see that works there. So that's basically how this method works, and I have a score counter which adds the amount of the value that you get to the score counter, and an update score method which can display the number right here. Then after that, it's basically the same thing for push left and push up and push down. The add right boxes is how you cycle through the matrix, and you call the push right method for the add right boxes, which basically it just adds them. And add random box. This is another essential part of the game. Once you add a box, you can see that this one just randomly spawned. I'll do that again. This one just randomly spawned. This just randomly selects a box on the grid, and it puts a value of 2 or 4. But the 2 has a higher chance of getting spawned, and that's just part of the game. It has a 90% chance, a 9-to-1 ratio between the 2 and the 4. And I show that here in the 2 and 4. It's 90% chance of getting a 2 and a 10% chance of getting a 4. This is done cleverly with a random dot next int. And if it's greater than 0, it means between 1 and the 10, that's going to be the 9 options that you have. And then if it is 0, then you're going to return to 4, which is the 1 out of the 10, which is a 10% chance. So then you have to reset isAdded, because you don't want to have isAdded be true when you're not adding anything. And game over. This is just to check if the game is done. So basically that's it here. I want to go over the graphical user interface. This button here is a general method, I mean a class I made, and it extends a GUI component. This component actually is an abstract class, and I made it because I can add all these properties to it, and I can make many different buttons, such as the menu button, select mode, and classic, and survival, and instructions manual here. And that's really helpful too. And this is visible, helps because since I have more than one menu screen, here's one here, and you can see here's another one. I need to be able to make it visible or not. And I haven't shown this yet, but I'm gonna quickly run through the game. I'm just pressing random buttons, and I want to get to game over, because that's when the game is over. And here we see I have no more moves I'm able to make, so the game is over, and I can just give it a prompt to go to the menu again, and I can just play. And all the error bounds are taken care of and everything. So this video might surpass 10 minutes, but I'll see if I can edit it down. We have a number picker, and this number picker allows the user to pick numbers within the range, and this is for the when you're selecting survival mode. This is the number picker here. You can go between 4 and 18. As you can see, you can't go past 18, and 18 by 18 is just ridiculous at this point. So that's basically it there, and the render is just simple color setting and drawing rectangles. Now the GUI screen has all the screens, the menu screen, the select mode screen, the instruction screen, and the game screen, and they're given a string here, and this string is what's referred, so you're able to actually call the screen, and basically just another render and update, and action listeners here for the mouse, so when you click the button, it gives you the corresponding action. Here we have the game panel. The game panel is obviously when you are in the game, this is the game panel, and it extends the GUI panel. All of these panels extend the GUI panel, except for the GUI panel, of course. And these panels are created using the GUI panel abstract property coming from the GUI components, and that's why the GUI component is abstract as well, because I can put any properties I want here: the mouse pressed, the mouse released, the mouse dragged, the mouse moved. I don't actually need all of these, but you have to load them up as an overridden method whenever you load up the mouse action listener. So these are all the panels. I'm not going to go over all of them because we're well over now. And yeah, I just wanted to go over the fact that there are like no errors here. It hits the boundary and it recognizes it, and you can play on. I also wanted to point out that I had this one tester method here. You can see it's called add box right here. It's not used right now, but it's to prove a point that this program is above and beyond what a normal 2048 game, because you can go any grid size you want. Because in a normal grid size, you can only get up to the number 2 to the power of 16, because this is a 4x4, which is a 16 box grid. So if I uncomment this here, this add box method actually allows you to add any box you want. And I just put the value here, whatever value for the box I want here. So to prove this point, I've added all the powers of 2, 2 to the 1, 2 to the 2, 2 to the 3, all the way up to 2 to the 16, just to show that you can't get past 2 to the 16. Here, once you start it, you can see that the highest number you can get is 65,536, and there's no other 2 to combine with this 2, combine with this 4, combine with this 8, and to actually form a bigger number than 2 to the power of 16. And that's why with mathematical probabilities and investigation, such as an IA with math, the survival grid, when you start it, now you can actually get past this number. You can, whatever grid this one, 2, 3, 4, 5, 6, 7, 8, it's actually now an 8 by 8, which is 64. So you can go up to 2 to the 64, which could be an interesting thing to investigate there. So I'm just going to go ahead and delete this now. And yeah, that's pretty much it for this video. That was my final project. We're about 3 minutes above, but that should be fine. And yeah, thanks for watching.
Do you like to type? Are you hyped for your type? I'm Lance Povey, and here's my computer science final project. My lovely assistant, Sully over here. Let's hear it for Sully.
Let's make them shake.
But you may be wondering, Lance, what is typing? That's what I'm here for. That's what you're here for. Allow me to show you. Of course, with the TypeHype program. That's just the intro. As you can see, there's these strange symbols on screen. Common English studiers and philosophers call them letters. These letters actually appear on this device right here. This device, you'll need to get this extension if you want to use this program. It's called a keyboard, from the Latin term key, meaning destruction. And the purpose of a keyboard is to type. To type is to classify something. You see two groups, and you classify them. Type A, personality. Type B, personality. That's an unrelated example, but you probably all know what typing is already. So what you want to do first is not use the keyboard, but rather use this device, a mouse. Most likely you'll have a plug next to your mouse. I don't have a plug next to my mouse, because my mouse is actually turned off. But it doesn't matter, because I'm going to use it anyways. Let that finish. A little bit of a sound effect. Personal preference. First, we're going to be going to the text files location. We'll go for, not tutor, we'll go for an easy one. Start things off. Let's go for some QWERTY ASMR. And we'll go for the single option. Now there's three options. There's single, multi, and story. Single, where it's word by word. Multi, where it's multiple lines. And the story, where it's pretty much a story. So first, you can see here, there's a selection of numbers. Now don't get this confused with your calculus class. What you'll want to do is use those numbers and click the corresponding buttons next to those numbers. So you see a 1 that's highlighted. You have to click the 1. Either this one or this one. But make sure this one has numlocks on. Okay? So 1. Okay? What comes after 1? That's right. 2. And then 3, and then 4, and then... That's wrong. It's 5, not 7. I don't know why you'd think 7, but hey. Then we come up with this weird word, QWERTY UOP. It's actually the first row. They call this the top row. I like to call it the QWERTY UOP row because it just makes sense. So you see those right there. You want to make sure to click the characters that correspond to the text on the screen. So you see a Q, you put Q. You see W, you put a W. You see R, you don't see R. You see R ahead, but you want to make sure you do E first. E, R, T, Y, O, U, O, P. Because I'm OP at typing. Next, you'll see what many people like to call the home row. That's actually incorrect. The proper terminology is the homie row. Because you're my homie for listening to this video. JKL. And then we see Zixvibinminum. Zixvibinminum is actually the bottom row. The Zixvibinminum row. So what you want to do is type in for Zixvibinminum. But then you'll see it's reversed. That's like to practice. Though actually, I've been tricking you. You see the way I was typing? I was typing with one finger. That's wrong. If you're typing with one finger, that's a lifetime sentence in prison. Alcatraz Island, ever heard of that place? Prison. Tough life. What you want to do is place each of your fingers on a character. So A with the pinky, S with the ring finger, D with the middle finger, F with the next finger next to the middle finger, and G next to the middle finger next to this finger next to this finger. I memorized typing positions, not finger positions. So then you do that, but flip it with your other hand. So this, then this, then this, then this, okay? A lot of this. But you may be wondering, if my fingers are stuck here, how am I going to reach the other keys? Well, there's something called flexing, okay? You have to flex to the other keys. So you're on the J, flex to the M, flex to this, flex, 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 of course. And then this is the home row, of course. Then you move it. You move your fingers there. And you keep on moving it, just like that. These last few are a little too tough for me, so I'm just going to do it the finger like that. And the numbers, I don't know how to do the numbers. I'm not an expert at everything. I just have a bachelor's degree in typing. So let's open another file. Let that finish, of course. I think it's still going. Okay, so first you gotta open another file. It depends where your text files is. Most likely it's located in the project itself, like in the project folder, the source folder. Don't worry, you don't need to know coding to use it. So let's go with the 3-star difficulty, normal. Oh, here's the one that I really like. Famous quotes. I hope I'm on there. Multi. So here you can see that these words actually are pronounceable. Let's read it together, okay? There once was a man from Peru. Peru is actually a city in Norwegia, who dreamed he was eating his shoe. He woke with a fright in the middle of the night to find that his dream had come. That's wrong. It's true, not rue. I don't know what rue is. You know, we've come so far that I think we're ready for the exam. Now, don't take out your notebook because that's not allowed on the exam. Let's open it. Gotta let it finish. You know, don't want to be rude. So we're going to go to the text files, of course, familiar location. You've been there plenty of times. We're going on 4-star, hard. Okay? We got a lot. Let's go for this song. Supercalifragilistic, The last option, well, it's lunatic, but we don't talk about that option. Instead, I'm going to be showing you how to make your own text files. That's actually a feature in the game. So you want to go to the text files location. You'll see number 1, tutor. You want to go to tutor. You'll see these custom files with this weird blue border. You want to open it. And then you click one of the options, single, multi-story. But you'll realize it's empty. Why is it empty? We'll close that and actually go on to File Explorer. It should be under my computer, my desktop, my hard drive, but it's not mine, it's yours, so it should say your computer. So we're going to go down on Documents, go to the text files location as usual. Sorry, I thought there was going to be a rock instrumental thing there. And then you go into the tutor option. Click one of the custom texts and type something out, of course. Let's do something simple, something memorable. Hello, my name is... That's right! Bobby McIntosh. Save that. So now, you want to open the file. There it is. Let it finish. So we're going down to Documents. Going back to the text files location, should be a familiar place. And we're going to Tutor. Remember the number that you put it on. I put on custom 1 because that's the easiest number to remember. In fact, the only number I remember. Custom 1, go to multi. So here you'll see he has insurance, don't worry. And it's there! You may be wondering, how do you do it, Lance? Well, I just showed you. That means you weren't paying attention. Go back and rewind the video. Hello, my name is Bobby Macintosh. Very nice. Though I forgot the period, I'd fail an English exam because of that. I hope that you enjoy typing as much as I do. Me and Sully from the bottom of our heart, we know you appreciate it too. That concludes my final project. Hope you all appreciated it real good.
Hello, my name is Joo-Hyung Kim, and this video will present the game I created for my computer science IA, and it is called the Panda game. The genre of this game is 2D sandbox game that you can enjoy adventure and survival like Minecraft. And this game is purely made out of Java, so I was able to have the full control over my game. And this is a start button for the game, and this button in the corner is a help button, which shows the basic controls. And if I press start button, it's gonna show you the menu screen, which this list is a list of the maps I have. Right here I can scroll up and down, and the button to the right, this one is start game, and this is making the new world, and this one lets you delete the world. If I select the world and delete the world, it's gonna show you the confirm dialog, since you don't want to accidentally delete a world, you know? And if you press yes, it's gonna delete the world. And if you do not press anything and try to delete the world, it's going to show you a warning message like this. And let me make a new world right now. For the name of the new world, as a programmer, I cannot resist to use this word, which is hello world. I mean, you gotta use it, you know? You have to. And for the seed, it's optional. It's like a key code for the map, but it's optional, you know? If you try to put something weird, it's gonna not let you do it, so I'm gonna leave it blank. If you press start, it's gonna generate the map. And here you go. These are some monsters that I summoned manually to show you the monster in one place. However, they do naturally spawn in the wild. There is actually a code that does that, which is called, if I go to entity natural spawn, it naturally spawns entity, such as those wolves, with certain, you know, intervals, and it determines where to spawn it. It's a cool method. There's also radius around the player that allows to spawn around. So going back to the game, this one is a wolf and this one is a golem. They're both hostile mobs, so they chase me. And this red dot is the visualization of their path taken to chase me, and this method is using the algorithm called the A-star pathfinding algorithm. It's an elegant method to find the shortest path possible from A to B, and let me show you the code for that one. It is right here in the AI section. There's actually a lot of AI for pathfinding. So A-star pathfinding algorithm is actually a very complicated method to cover in this video, but abstractly is recursively looking for the surrounding tiles and connecting the one with, you know, show this move cost, which is distance from the target plus distance from the start. And by connecting those tiles, you can get the path that is shortest from from A to B. It's an elegant method, you know. So I don't want to get killed by these guys, so I gotta escape. And actually, there's another monster right here, which is the red tree. I marked it on purpose because normal tree drops item like this, but the monster tree, you touch it, it becomes monster. So I'm getting chased right here. However, I could change the targeting of them, which is right here. I go to wolf and change the target method to target not player but golem, for example. And if you go to golem and change the targeting to wolf, it's gonna target each other. Now I need to quit the game, but I could use this prompt to quit the game, but I could also use this X button right here, since it automatically saves the game, which is very convenient. Now I'll start the game again. So if I run the game right now, the monster should target. I start the game. These monsters are stuck together, fighting each other, and I'm gonna get out of here. So, and the final entity right here is an entity called Peter, which is requested by a client to make a replica of in the game. It occasionally talks about the random facts, but since it's annoying, I'm gonna kill it. And when the entity dies, it makes a sound, but unfortunately this recording device and recording program cannot pick up the too bad. But I could show you a sound class, which is right here. It's actually a bunch of enums I'm using. So it has background music too, and it has some entity sound right here. Now let me show you the inventory feature in this game. If I press I, it shows inventory. I can drag and drop the items. And here we go. I need the apple. And if I press the 1 to 5 key, or if I press the slot itself, I can choose the item, and if I press space, I can heal, or I can use a fence to block the monsters. And for the crafting feature, I can press C, and it's going to show you those categories here. But there's not that many categories to actually fill up the space right here yet, but looking at this one, I can make a wooden fence by this button or pressing space. But if you're trying to craft something that is, you don't have ingredients, then you can, as it says, you can press the recipe to check the ingredient, which is shown right here. And some items like this require higher crafting level, which is achieved by using crafting table. And now you can craft the one with higher crafting level. And let me move on to the map part of this game. As you might have already noticed, this world is a randomly generated map, and it's also infinite world. I can show you an example of a map, actually part of a map. Right here is 1000 by 1000 map. It shows a lake and the beach surrounding it, grassland, and desert right here, and the mountain area right here, and a patch of snow, and swampy area, and some forest. So there's quite a lot of biomes in this game. And this randomly generated map works by using what's called noise. There's just a bunch of random numbers put together, and by using elevation and moisture, you can create biome. For example, if elevation is super low, then it becomes a lake, and if elevation is middle and moisture is high, then it becomes jungle. And for the infinite world feature, I use a method of dividing the world into chunks or areas and loading them as the player moves toward them. So chunk contains a list of entities and items and tiles within that area. By using chunks instead of individual tiles, I don't have to worry about updating the tile by tile individually, which might cause a lag. And next I want to talk about is the lighting system in this game. Now let me, for the lighting, I gotta get to the dark area, and let me go to this cave. I can use this campfire to light it up. Here, or a torch. As you notice, this light do not penetrate through the wall, which is natural, but it is done by using what is called Brazenham's line drawing algorithm to draw a line toward A to B, and checking if there is a solid block that is blocking the light. Just like in real world, if a ray of light is blocked by a solid block, then it's gonna stop and cast a shadow behind it. And by the way, this campfire actually burns the player, so you gotta be careful. And before I close the program, I want to show you this screen that shows when you die. Which is, you never want to see this. Anyway. And there's actually a document called development instruction in this game folder. It's basically a document that lets you know what to do to add a new feature, like adding items or crafting recipe. It was also helpful for me to organize this procedure to show how to add a new feature in this game. It's very thorough and step-by-step procedure to add new features in the game, so even people who do not know what this game is can add a new feature in this game. And, well, that is all I have to say about this game, and have a nice day.
Hi, my name is Bailey Smith, and I'm from Winnipeg, Manitoba, and here's my final project for IB Computer Science. So if you load it up, we're just going to, if you start it with nothing in there, you have to add some new students. So we're going to add a couple. So he's grade 1. We also set minimums, so I can't go any lower than grade 1, no younger than 5, and no lower than math level 1. So if you add him in, Sally here, so she's a grade 3, age 8, maybe a math level 5. Add another one, Bob. He's set a maximum of grade 12. An age of 21 because that's when public schooling ends here in Manitoba. It's in math level 3. Say John here. Now let's say John left the school system, we can delete him. If I tried to delete a student without selecting one, it would warn me. Same thing with load. So let's just load up Dave here. He doesn't have any past results because he hasn't achieved any past levels. So we're going to start with level 1 here. This is basically a test on just basic counting. So imagine he passes, which means you get more correct than wrong. So he got 2 out of 3. He now moves on to level 2. Now if I load him back up, I can actually go back. And let's say he gets all of them right this time. Now, the only thing that changes, he stays on level 2, but when I load him up, the score here changes. So I can go to previous levels, but only ones I've previously achieved. And I can also now do level 2. And if he were to fail this level, I'll just show you the message that he would get. He gets some right, but not enough to pass. So 4 out of 10, and then I have to, going through that, I have to retake the level. So it says here that I have to retake the level. So let's load up Sally here, and because I don't have any previous data from the levels before, it just automatically fills them in as 0. So if I wanted to just start with level 1, I could go back and do level 1, and this should be pretty easy for her since she's on a level 5 right now. So the moment she does that, it still keeps her at a level 5 because she was just redoing a level. So if we load her back up, we just have a score there. So if she were to start level 5 now, and she were to pass, not get all of them right, but pass. So 4 to 5, she now moves on to level 6. So if we load her back up, we see that she has now a score for this, and those still remain 0 just because she has not completed those scores and she hasn't done anything, so it just automatically fills in. So if we were to hit, if we load the wrong student, we hit back, gives us some more. Let's say Sally got moved to another school or whatever, we could just delete that information, and then she's gone. And we could load up Bob here, and same thing here. So if we want to go back and previously achieve, let's say level 2, we could. Let's assume he passes. And the question length for each question varies, but now it says he got 8 out of 10. So if we go click on him, it just loads up the score there. So we can always add a new student. As long as we don't exceed the maximums, that's fine. So now he's loaded up, and if we load him, same thing. Now if we look over here at some of the code, so I have linked lists. Linked lists I actually created, and there's I use quite a few of them in the program, and they're all generic types, and that's to keep track of the nodes. And there's actually linked lists of the questions, and then we have all the levels, and this just kind of calls everything. And then we have level, which is connected to question, which is connected to question data, which is connected to all user data, which implies uses arrays and other linked lists, and this will eventually call other linked lists. We have a file handler of generic type T, which saves all my files and also keeps track of and watches for try-catcher block errors, and that's for different things that are saved. And then if you were all done with the program, just load them up one more time. See if we want to go and achieve level 2 now. Let's see, he got enough to pass. It's all pretty simple. So we get here, and when we load back out, his thing will be there. And let's say we want to get rid of him, we can just delete him and end the program. Just simple, cancel it out, and then we load it back up. Those two are still there. So that is my final project for IB Computer Science. Thanks.
My name is Akil Muki. I'm from Winnipeg, Manitoba, and I attend Sturgeon Heights Collegiate, and this is my internal assessment. So a little bit about this project. This project is a 2D action platformer that uses pixel art as its main graphics. So as you heard there was the main menu music playing in the background. So in every scene, there will be music playing. From this is the menu scene, and then it'll go to the level menu scene, and then the game scenes, which all have music playing. There are also multiple sound effects, from actions ranging to button clicks, to the player jumping and collecting consumables, and the enemy getting hit. So right now, as you notice in the menu scene, you see that there's a parallax background effect going on. What this means is that the very back of the scene, there is a bunch of pixel clouds moving at a faster speed than what is closer to us, which is the trees moving at a slower speed, creating a cool effect. Only one button on the screen which the user can click, which is the play button. So when we click the play button, we will go to the next scene, which is the level menu. So as you see on the level menu scene, there's only one level unlocked, because this is the user's first time entering the game. So if he or she tries to click on another level, it will give them the text level locked. And he can do this multiple times, and it will do the same thing, signaling that they cannot access the level. Next, if you go back, there's a back button going back to the menu scene. So this is just the same scene from before. So we can actually go to level menu again and click on level 1. And you can also see that there's another parallax background effect going on. So let's click level 1. So level 1 starts off with the easy tutorial, just demonstrating the game mechanics to the user. For example, it says welcome to Pixel Line. Use A and T to move. So that's what we're going to do. So the user can use space to jump, and there's also a double jump feature implemented in the game. and you'll see multiple tiles. So this is the moving tile. This tile is the normal tile, which doesn't do anything. And there are also teleporting tiles and tiles that make you jump. In addition to that, you can see the player has multiple animations for walking, for jumping. If you look in the top left of the screen, you will see that there is hearts, coins, and the middle of the screen there is a score, and the top right of the screen there is a play button. So essentially what the play button does, it just pauses the game scene, freezing everything with the text paused, and then it has a few options. So what this is, it actually mutes the audio. This actually just reloads the scene, so if we click it, and this one just takes you back to the home scene. Simple. So if you progress further into this, we can get to the end of the level and demonstrate more of the tiles. So this is the teleporting tile, and this is the jumping tile. So it also says jump on an enemy's head to destroy it. So if you jump on enemy's head, the force will be added to you, so you'll jump even further and you will destroy the enemy. So progressing down the level, you will also see that there are two types of consumables: hearts, which give you health, and coins, which give you points. And if you do notice, both text are updating as soon as we touch the consumable. So another jumping tile here. So this is the third coin in the scene. And another enemy, all you have to do is jump on his head. So, and we also have a mechanic where if you touch a door, it'll progress you to the next level. So if the user touches the door, he'll progress to the next level. So now we see that the stats reset, same with the score. So if you go closer to the barbarian enemy, you will actually see him attempting to hit you, and he will kill you in the end, forcing you to restart. So if you also notice, if you go back to the home menu, and then to the level menu, level 2 is now unlocked. So then the user can click on level 2, but the user still cannot click on level 3, 4, 5, or 6. Like that. So if we actually exit the game scene, we can see that there are multiple folders here that sort our project out. These range from animation controllers to audio to scenes to scripts. So if we actually go to the scene folder, we can see that there are all the different levels here. So if we go to, for example, level 6 or level 3, they're both completely different. So if as we zoom in, we can see that there are multiple types of enemies. So this is the wizard enemy, which shoots projectiles at you. There are also multiple puzzles the user must complete. So if we actually hit play, you will notice that the level is already much more difficult. So if we try to jump to this block, and then here's our wizard enemy. All the wizard enemy does is shoot projectiles at the player, and as we get hit, we lose 1 life for each time we get hit. And then we eventually die. So let's try that again. So if you jump on the wizard's head, it does die normally like all the other enemy types. So same with this guy. Another feature of my internal assessment is that when played on multiple resolutions, all the images and graphics will change based on the resolution. For example, here we are in free aspect. If we change the aspect ratio, the UI will scale appropriately, and this works for multiple cases. Let's take a look at some scripts. So we go to the script folder and we see all the scripts used in this project. So the one I want to show you in particular is called UI controller. So as we open up the UI controller, we can see that this class controls all the UI elements in a certain scene. So at the start of this script, we can see that we add all the possible UI elements to the linked list that we have created. So what this does is that if we want to set values for a linked list, or if we want to change the value of a certain UI element, we can easily do so by accessing our user interface linked list. So what we do is we add the object to the linked list using this method right here, which also error checks if the parameter passed is returning null or is returning the actual game object. So we do this by searching the scene for a game object with the tag. This concludes my internal assessment. Thanks for watching.
Hi, my name is Jordan Lanway, and I'm from Winnipeg, Manitoba, Canada, and this is my computer science A. I know it says math IA, but trust me, it's not. I did use this program as part of my math IA, but this is my computer science IA. So let's just launch it then. This is the base damage calculator for Tom Clancy's The Division. Sorry, that was just test. So it's a J-frame. It's not resizable. Of course, you can move it around. We decided that it didn't need to be resizable, my clients and I, that because, I mean, who needs a calculator to be full screen? So we decided to just lock it and then hard code. I decided to just lock it and hard code in the position of all the elements on it. So speaking of the elements, there are 4 labels, 2 text fields, 1 combo box, and 4 buttons. So the program can be closed either with the quit button or the X on the top right. Sorry, you'll see that file saving come back later. So I'm going to enter in an integer number for the firearms, so 7390. That's about what I have on my current character in The Division. I'll grab a random weapon here, the M4, and I'll take a random base damage. 19,200. Sorry, not base damage, weapon damage. So I'm going to click confirm values. So that's going to turn these into integers from strings, and then we click calculate. So here we are. A pop-up message box has come up. The base damage is 9,962.5, and the percentage of possible base damage is 97. So that 97 is actually likely not a perfect 97, but I use the round function because I don't really think that anyone likes looking at percentages with decimal points. So let's talk a bit more about that combo box. So inside of here, there are 50 some odd weapons. I believe it might be 55. And it's an array that's been placed into the combo box. An array of type weapon, which of course has the constructor here. So at the bottom of this class here, there's a huge array sitting in that method that I like to keep closed because it looks kind of ugly. Let's talk about the file saving. So again, if I type in, let's say 7390, and I click the save button, that's going to write this value to a file location that I've specified in the code. If I click quit, it'll close the program, and I have it set so that the open method, which is right down here, runs on the opening of the program. So you should see that 7390 in this text box again. My clients ask for this because they don't change their firearms value very often. That's the value on your character, not on the weapon. So that is pretty often the same as the last time that they came into the calculator. Meanwhile, they asked that these two were not saved because there's no need. It just had an extra step. You don't want to calculate the base damage of the same weapon twice, you know? There's no need to do that. So there is, of course, some room for expansion on this program. Personally, I'd like to add more error checking because, as you saw earlier, I could just enter a bunch of gibberish and still save it to the file. Of course, the file saver still works, but the only thing that matters here is an integer number, so saving a bunch of letters just seems kind of stupid. And if I try to trigger a calculation with that, yeah, that's going to create a huge error there. So what would be better is if it checked for that and popped up with a message box saying something along the lines of you can't enter anything besides numbers. Just that stops the program from crashing on people who are actually not running NetBeans. The good thing is that I do have some degree of error checking with the save and open methods. They're in try-catch loops, and both have errors with writers or errors with opening file. If I say change the file path here, let's just do that. So that's going to purposely mess it up. And when I open the program here, it's going to very clearly tell me what's wrong. It's going to say error opening file. It's going to tell me the fake path that I've entered. The system cannot find the path specified, so that means, oh, I've got to come back here and fix the path. One thing that I would like to do with this, though, is figure out a way to make this so that you wouldn't have to have NetBeans edit this, because I would like this program to be used by people who don't know Java code. So in the future, I'd like to include this program in probably like a folder that if you place it in a certain location on your computer, the program is designed to pick up that file location, so that you don't have to worry about changing this location every time you move computers, because I'm on my personal computer now. I did most of the coding on one at school, and I had to enter the new file location when I did get here on my personal computer. And that's it for my program. Thank you for watching.
Hello, my name is Brody Wainwright, and I play on 2 sports teams and coach 2 others, which is part of why I decided to create this program. This program, the Coaching Assistant, helps you keep track of how long all the players on your team have been on the field. Okay, so to start this program, you're going to put in your information. Now you would proceed and click Create Coach, but I'm going to go into the coaching code and show you what I used. So the coach will have a roster of players, and the roster is a linked list because the roster can shrink and grow, and we need to account for that. And but then the coach actually has a linked list of players, which is called rosters. So we can have multiple rosters and mutate how many rosters he needs depending on how many teams he coaches. As well, these linked lists that you see are all part of a linked list class that I wrote. Alright, so now we're going to go back to the program, and we're going to create the coach. So now we're going to do this. Now we're going to be adding players to the roster. So it's going to be the same system as when you first put in your information for the coach. I'm going to do that quickly with some random names. And now that is added to a temporary linked list that holds them in memory, and then you can add them to a roster afterwards. So I'm gonna continue and add the rest of them. Okay, so now that I've made all my players, I will click this button. We'll add roster to add this this roster to any of these other rosters. So I'm going to select one of the 5 default rosters. I'm just going to click number 1, and then I'm going to add to it. If you add to it and you have a player that you don't want, you can remove a player, and it will remove at whatever spot is here. So then you can click through and do it. But I'm not going to do that because it took quite a bit of time, and I don't want to waste your time. Okay, so now that I have a roster, I can start this game. So now this is the playing field, and it has a bunch of different positions. Each of them is in a position box, which is his entire box, and each of the position boxes has a playing player box and a position a substitute player box, which is right now represented as a button. So I'm going to go into the code and show you that. So first off, I'm going to look at the position box, and it has as parameters when you create it, it has the name of it, and then the playing player roster spot. So that's where whichever the player in this box comes from in the roster, and then same thing with the substitute spot. So then those can, and then also takes in the actual roster. Now you can, it creates a label with the name on top, and then it creates the playing player box and substitute player box. The playing player box has a bunch of labels on it, and which displays its name and everything. Okay, so now I'm going to go back to the program, and now I'm going to start the timer. So this will make all of these numbers count up as that they're all in the field. So 1 second has passed, and now all the timers are going up. And now what you can do is you can add a substitute, and then you can substitute one player for another, and then the next time you substitute, it will do that. Okay, and thank you for watching, and that's my program.
Hello, my name is Peter Miro, and welcome to my final project. JRS stands for Journal Research System. It's designed. I designed a journal so that you are recording your entries of what you did, how you felt, all that, so that you're able to learn more about yourself. Hence the research system part. All right. My application is graphical based. All right. I'll just go through my code for a moment. My code is split up into 5 distinct parts, really. My data part, my graphics logic support, UIO, and random. The random class is responsible for generating random values, which is sometimes used in the application. UIO stands for Universal Input Output. I've designed it so that all the input and output of the application goes to a central location, so it's easier to debug and less code that's repeating itself throughout the entire application. GUIA modal, I did it for deduplication so that all the code, I noticed I was doing the same sort of code in a lot of my windows. I just moved it to a central window so it was easier to manage. This is my GUI logic. The menu manager actually was very fun to build. So on most applications, when you do things, different menu options become available or disabled. So this just allowed me to have a central place to enable or disable menu options. And I just passed the menu bar and the menu state I wanted to be in, and this just did the rest, so it's very easy. And this is my main application logic. It's just responsible for updating the text, the loading and unloading of journals and application entries. This just loads the journal, requests to load the journal. This is the entry class, which is responsible for keeping track of the entries that you wanted to load and the entries available to load. The created entry class, which is pretty simple, and that was create a journal, and this is create an entry, which is very simple. And without And then this is just GUI, which I used in a J, which I just used using drag and drop, and I coded all the buttons myself. Constants is things that do not change while the application is running, and makes it so the code is easier to read. And globals are things that do change while the application are running, and instead of passing the data around, it's just stored in a central location. Alright, let's start the application. Alright, so as you notice, a window pops up. It's pretty plain looking. You can create a journal. What's the journal name? I be stressing. The parent, you can either manually specify by typing it in here, or me being lazy, I'm just going to put it on the desktop. Shoot. So this is the desktop. I'm saving to the desktop now. So now notice the entry has changed and shows the journal that's loaded. I can now create an entry. Sample entry. Notice when I did an entry that this little star appears, which shows that I've edited the entry, and that shows an entry has been loaded. I can now click save an entry, and the entry is saved. Now if I don't like the entry, if I want to switch to a different entry, I can click close and create another entry. If I select an entry if I'm trying to create an entry that's already been selected, it prevents me from creating it. I can click that, and now I click create entry. I can now create another entry, another sample entry. Now if I'm done with, if I let's say unload, it's saying now if I want to unload a journal and I haven't saved an entry, it will show this dialog asking me, do I want to unload save the entry before closing. If I click cancel, it cancels the closing operation. If I click yes, it saves the entry, then closes. If I click no, it doesn't save the entry, and then closes. I'm going to click cancel, and then just save manually. Now let's say I want to open another entry. I click open, I can choose the entry I want to load. I have loaded it. If I don't like an entry and I maybe don't want it anymore, I can click delete, and I'm really going to delete the current entry. But I can also unload an entry so that I restart. Now let's say this is a different session. I load. Let me find it. Where's desktop? And there it is. So I just load it again. Click journal. I can edit the journal name, so if I don't like the journal name, I can change it to something else. Peter's journal. And click OK. It's now saved. But now, let's say I don't want the journal anymore, along with all the created entries. I click journal, delete, and I can delete the entire journal with all the files associated with it. The other thing I designed with my class is so that it was able to handle read-only locations too. So if you loaded a journal that was read-only, it would prevent you from editing an entry, but allow you to still open and close entries and journals, but not edit it. The deleting method only deletes entries created by it and not by any other program, which is really nice. Anyway, that concludes it, and thank you.
Good morning, I'm Christian LeBrun from Winnipeg, Manitoba, and let's get going. So, my computer science IA is a map program. So what it does is it takes a series of intersections that are connected in various ways, and then it can calculate the shortest route between them. So let's get into the meat and potatoes of this whole thing. So we have the intersection class. So what this does is it creates, or it allows you to create an intersection, which is just like 2 coordinates, and then it contains a linked list of all the neighboring intersections as well. So the intersection this one is connected to. So it has 4 properties: x, y, the coordinates, visited, which just marks if, say, in the navigate method in the linked list class, whether or not this intersection has been visited, and then a linked list of intersections called neighbors. So that it can add an intersection, and then when it adds an intersection, it also adds this intersection to the intersection we're adding to make sure they both reference each other. It's not just a one-way reference, which could be problematic. Some accessor methods, equals, which only looks at the coordinates. It doesn't look at if neighbors are equal, which would be important later on. ToString, which goes to this intersection and then goes to all of its neighbors and outputs them ToString as well. So we see some recursion here. We'll see the use of visited to make sure we don't keep looping back to the same intersection over and over, which again would be problematic. We have some mutator methods: visit, reset, which chain visited, and then an accessor and been visited. We have ones that get how many neighboring intersections are, one that gets a specified intersection, and one that calculates how far 2 intersections are using the Pythagorean theorem. Okay, now we have the map class. So the map class has one property, a linked list of intersections. This could be replaced with recursive methods, but I already have the linked list all written up and ready to go, so I figured I might as well use this linked list rather than write a whole bunch of new recursive methods to do, to find a specified intersection or something like that. As I figured this would just be simpler and faster. So we have 3 constructors. The first one makes use of the second one makes use of the third one, and then they just create a certain intersection and instantiate the linked list. We have, so lots of these methods take coordinates, and then the ones that take coordinates will then just make an intersection and then call the version that makes an intersection. So the coordinates one is just useful for user input. And then so we have this one contains and just goes through all of them and all the intersections in the linked list and check if they're equal to the one we're looking for. Add again, it has 2 versions. So first we want to make sure that the one we are adding to, connected to, it does exist. Then we want to grab that one. We want to grab connected to from our linked list, because the version in connected to here, as you see, it's a new intersection. So it's just the coordinates, but when we grab it, we'll grab the one with all the correct neighbors and stuff. Then if the one we're adding exists, we want to grab that one from the linked list, because we might be connecting 2 pre-existing intersections. It's possible and likely. Otherwise, it's more or less just a line, or if you can have some branches, it'd be a tree. But this is a bit more complex than a tree. So we have get intersection, which again just grabs a specified intersection, so it loops through all of them, and then checks to see if the one that we're looking for is there, and then if it does, we return that one. So we give the coordinates, and then we get the neighbors, practically. Then we have navigate. The one with the coordinates is a bit more complex, but it's the same idea. But this time, instead of just creating a new intersection, we're grabbing the proper intersection with all the proper neighbors and such. So here we have navigate, which is kind of the meat and potatoes of the whole thing. So it has a route, which is a linked list of intersections, current, and there's a linked list of options, or linked list of routes called options, which is all the routes that it can possibly find from this point to the end. We make use of visit just to make sure we don't keep returning to the same point. And then here we see, again, recursion, where it will calculate the shortest distance from each of the neighboring intersections to the end until eventually, you reach the end, which is this starting section equals end intersection. They'll just add this to the linked list, and then we'll return a linked list, which mostly just contains this one point. And then they'll add that, and then we'll finally eventually get free of the loop once it goes through all of the possible paths. And then it keeps clearing up current each time, resetting all the points except for the starting point, because we don't want to return to that point until all of its possible routes are found. And then we're kind of done as that one as a starting route, because then once we go above that point, then we might want to use it again for a new route. but while we're kind of below that point and all of that into that point's like connected points, we don't want to touch. We want to go back to there because we've already been there on that path. The shortest, which just compares all the routes and sees which one is the shortest, and then toString, which just looks at the first intersection in the linked list and outputs that, because that one outputs all the other linked lists it's connected to. So we have route, which I said is linked list intersections, toString, that just says here's the route, and then gives us the length as well, which can be useful. Route length, that'll do is it'll loop through all of the intersections and then find difference from the first intersection to the second intersection, to the second intersection, to the third intersection, and then adds that all to the total route length. Clone, which just creates a copy of this route, which can be useful because as you saw earlier when we cleared out current, so we didn't want to lose all that data, so we cloned current rather than just having it set them equal, because then it would still act the same one. And then contains, which just checks if an intersection exists in that linked list, or in that route, sorry. So the map interface is what allows us to kind of access the map and look at all the fun details. So we'll kind of look at that now. So the first thing it does is get the starting x coordinate, so 0 we'll put, and starting y coordinate 0, and ask if we want to expand on that. If we want to keep building off of this point, we'll say yes, and then we do 1 as our next point, and then ask if we want to expand on this. So here we see some recursion again. So expand intersection. Yeah, so here it is. So what expand intersection does is it says, do you want to keep building off of this intersection? And then if you say yes, it'll say, okay, give us the next point. And then after you've done giving it that point, it's like, do you want to expand on this intersection? On and on and on and on. Forever. And then it does have error handling. So if I say I want to go to I, it won't accept that. So then if I'll build a couple more points. So 1, 1, let's go from there to 3, 5, oh, yes, 3, 5. From 3, 5, let's go to 2, 2, and it'll connect 2 back to 0, 0. This one creates a bit of a loop. And then do we expand on 0, 0? No. 2, 2, no. 3, 5, no. 1, 1, no. 0, 0, no. So then kind of loop this all the way back to the start. And then now it's asking me to create a route. So x coordinate at departure, let's go 0, 0, x coordinate destination 2, 2. Now what this is going to do is it's going to look for the shortest route. So there's two options, right? It's going to go 0, 0, 1, 1, 3, 5, 2, 2, and then goes 0, 0, 2, 2. Ideally, I'll pick 0, 0, 2, 2 if it does everything right. If it doesn't, well, then we've got a problem. And it should do that because I wrote it and I tested it and it seemed to work before. So let's test it now. So it's going to check all the routes, and yeah, so it picked 0, 0, 2, 2 and gave us the length of that route, 2.82, whatever, it's a long number. And then, so yeah, it picked the right route. And then we hit OK, and it's like, do you want to do it again? So there we are. There's some error handling here if you want to look at that. So it checks if an intersect error. So here, when it's getting all these points, we want to make sure they exist and everything. So there's a bunch of error handling in here. And then we create use of the input and output method or classes. So the input class is just a bunch of static methods that can get all sorts of input. So get integers and get yes, no's, and can check if things are equal. So that's just a very useful class to have, because that's just where all of our input goes in note through. But I think each time I to get yes, no, we're putting it in one class. So if we want to make a new interface class, we could. Output is a bit simpler, just output. So if we wanted to create new output methods, we could, and output in new ways, we could. Here's linked list. So it's a pretty basic linked list. It's a doubly linked list, so the head, so one point references the point before it and after it. So then everything can you can navigate the list one way or the other. It's fairly simple. It's fairly normal linked list, nothing too special about it. And then the node class as well, which is part of that linked list. All right, so that's all there is to it. Thank you for watching this, and have a good day.